Hi there, I'm Rudrash Devedi, and in today's video, I'm going to be talking about the solution for the first internal for the subject Introduction to Data Science using Python and R. This is presented for our instructor, Dr. Shaligram Prajapat, and this is a part of the video assignment for the third internal. So let's begin. We are given a case study of DSS on IPC BNS section mapping. A decision support system helps to find the right IPC BNS section for a police complaint in India. Police complaints are usually written in free text, they are not always clear or structured. To make them useful, the system must extract features that are useful. The DSS uses a knowledge base of IPC and BNS laws. It compares the features of a new complaint with the knowledge base. For this, it uses different methods like statistically held complaints. They're given their averages, ranges, and detect unusual cases. Similarity and dissimilarity measures to how close one complaint is to another. This helps finding the related cases and past examples. Data pre-processing cleans the complaint data. It fills the missing values, removes errors, and makes value comparable. The compatibility and pairing studies how different offense elements are accused combined. This is important for cases with multiple offenses or co-accused. A to D are practical steps for building a DSS that can turn raw complaints into clear legal insights. So the first question is, the given three commonly used statistical measures to characterize dispersion in complaint-driven scores. Discuss how these measures can be computed efficiently over large complaint repositories. So let's talk about this. What are the three statistical measures? So we have the range, interquartile range, and standard deviation. The difference between the maximum and minimum scores is the range, provides a quick snapshot of the data spread. IQR, that is the interquartile range, is the difference between the 75th percentile, that is the third quarter, and the 25th percentile, that is the first quarter. Measure the spread of the middle by 50%, and it is robust to outliers. For standard deviation, it measures the average distance of each score for the from the mean, indicates how clustered the data is around the average. These measures help in understanding the variability and consistency within the complaint-driven scores. Efficient computation for large data repositories includes the streaming aggregation, approximate sketches, partition stores. So the first one is calculating the sum and the sum of squares as data arrives. This allows the variance standard deviation computation without storing all the values crucial for continuous data streams. The approximate sketches utilizes data structures such as T-digest, KLL sketches to estimate the quantiles for IQR for with high accuracy in a single pass over the data, optimizing the memory and processing time. Partition stores compute the local statistics, minimum, maximum count, sum on individual data partitions charts that subsequently merge these local statistics to derive the global insight efficiently. Now let's talk about the question number two, where we need to compute the mean median calculations. Here we have the mean calculation, that is this, we need to compute the sum of the values. We need to divide this by the count of the values. Similarly, the median calculation, since the given count is not even, we need to choose the position of n plus 1 over 2, that is 27th position plus 1 over 2, that is the 14th value, and the 14th value in this sorted list is 25. So that would be the mean. Now the mid-range of the data calculation, mid-range is given by the minimum value plus maximum value over 2. So this is calculated as 41.5. Similarly, the mode is 25 since it appears 4 times, and 35 that appears 4 times. So both are mode. The result for modality is that it is bimodal, since there are two um, elements that are similar, that are equivalently frequent. So let's shift to the question number D and E. So the maximum of this data is basically the 13. The maximum observation, the 25th percentile, is given by the formula n plus 1 over 4. That is 28 over 4. That is the seventh value in our sorted list. That would be 20. And Similarly, we calculate the 75th percentile, that would be 3 into the n plus 1 over 4, that is 3 into 7, that is the 21st value in our sorted list, that is 35. The box plot looks quite similar to the quantile plot. The quantile plot displays the stored value against the rank or percentile, showing the sample data distribution. The QQ plot compares the quantile of sample data against the quantiles of theoretical distributions, used to check the data adheres to specific distributions or not, assumed under shared models. And the box plot illustrates the middle 50% of the evidence score lies. The long whiskers extend to 70, suggests that a positive skew is happening, indicating the presence of some very high evidence scores in the data set. Now, for question number three, we have a simple calculation. We just need to calculate the cumulative frequency, the lower bound, the upper bound, and the class width of the given data. The total frequency n is equals to 3194, and the target median position is 1597. So the median calculation is as follows: L plus n by 2 minus Cf, that is the cumulative frequency, divided by the total frequency into the H factor. So the median is calculated, thus the median calculated is 33.94. And let's move on to the question number 4. That is, we need to calculate the mean, median, and standard deviation for age impact. It is the same as applying the formula that we did in question number 1, question number 2. Uh, and that would be it. The box plot is shown in the diagram, and the scatter plot is also similar to question number 3. So this would be it. Thank you for watching.